Okay, so this is 11.1, and so this is our last chapter. And the first thing they wanted to remind you about was the distributive property. If what's in parentheses cannot be added, and this is a case where you can't add an x, which is completely unknown, to a 3. So x plus 3 is as much as you can do there, but you can distribute, and I think I used these kind of, somebody taught me to do this and I keep doing it. This is 5 times this and 5 times that. So 5 times x would be 5x, then it's plus 5 times 3 is 15. So this is not a problem, that goes very far, but it can be used in some of the problems we have. The book has this one. As an example. And the negative is actually right in line with the horizontal number on the fraction. But you see, I couldn't even write it that way. I have a tendency to do this. To bring the negative to the numerator so I can see it, because sometimes, you're tired and you're not paying attention, and it's like this all blends in together somehow and you don't see the negative sign. By bringing it to the numerator, it makes it easier to spot. So this is what we're going to do. It's negative a quarter times 8x. So negative 1/4 times 8x. This is what it looks like. That's that first step. And 4 can divide into 8 once, and this is twice. So this is negative 1 times 2x, negative 2x. So you work the numbers, negative a quarter times 8, and a negative times a positive is a negative, and a quarter times 8 is 2, and then there's just the x. And then finally, negative a quarter times 12, negative 1/4 times 12. And if we go back to the way we learned it with fractions, 4 goes into 4 once, into 12 3 times. So negative 1 times 3 is negative 3. Okay. So if you have to do the work on the side like I just did, then go ahead. But this is not a bad deal because in both cases, the 4 canceled nicely into 8 and nicely into 12. So there was some reducing right there in the problem. So that was one of the examples they showed you. Now, another thing, let me just go there. Okay. Another thing they wanted you to realize is that if you had 2 terms, what we've been saying from the very, very beginning of this course is that if you want to add, you must have like things. Now, the way it translates into algebra, which is where we're headed, is that if this is a x, 3x, 3 times x, and then plus 4 times x, those are like things because they have the same letter. So that means we can add them. So still not knowing what x stands for, we have 3 times x and 4 times x. 3 and 4 make 7x. You could make a project out of that computation, but the truth is you're adding the numbers and copying the variable x. So let's see what we've got. So if I have 7x minus 5x, and then I have plus 6, subtract 4. And the instructions on this would be to simplify. And so the very first step when we solve an equation is simplify. Quit this mess stuff and make it as simple as humanly possible. That means that you have to add like terms. These two, there's 1, 2, 3, 4 terms right now. These two are like because they both have x. So this is a subtract, but who cares? 7x, subtract 5x. 7 take away 5 is 2x. Now, I've got these two, which are also like terms. They're both just plain numbers. Let's just call it that. So I have a plus 6 and a subtract 4. And 6 subtract 4 is 2. Now, I could write the 2 down, but that would be a mistake. I need to put a sign between these. And this is a plus 2, and so I need the sign. If I didn't put the sign in, I would have to take it as multiply. 2x2. Without a sign, not having a sign means multiply. And this is not multiply, this is actually add. So these two went together for 2x. These two went together for 2, but it's a plus 2 that needs to be there. And now, if this looks like this is unfinished, it is because we're just practicing. We're just practicing simplifying. And so here's another one. 4a subtract 3, subtract 5a plus 2a. All right. What I want you to do is see that the subtract and the add separate the terms. And so I want you to see them as 1, 2, 3, 4 terms. And then your job it would have said simplify. Yeah, that's what it says. And so now you want to see, are any of them alike so that you could combine them? And it turns out this one, and this one are alike. They're both a terms. So it's the first one is 4 times a minus 5 times a, or subtract 5a and 2 times a. And so those are all alike. And so we need to put them together. So it's 4a subtract 5a add 2a. So we've got to find a way to put them together. And then this last one is just subtract 3. There's nothing to do for it, but just put it at the end. And so let's think what this means. It's 4, and then you take away 5, but then you add back 2. Anybody want to venture a number or a number and a letter? How much?
1a.
1a. So you can do this 2 ways. 4 take away 5 is -1. -1 plus 2 is +1. Another way you could have done it, because this was all in a sense add, this is 4, we have 4 in the positive side and 2 in the positive side. That makes 6. And then 6 take away 5 is 1a. Subtract 3. Now, as it turns out, the way they like answers is always the simplest way humanly possible. And we've done this all along. If you had 10 over 2, you said 5. And anytime you could make it, it's the simplest version of the answer you do. 1a is assumed to be a. And so although this is technically correct, they will write it like this because they don't want extra stuff. And so A is really 1A. These two are identical. But the tendency is just to say A assumed it's 1A, or 1 times A, and then subtract 3. Any questions on that one?
Huh? No, I'm kidding.
Huh? Is that what you said?
Yeah,
Did you
I'm
get it or not?
I got it.
You got it. Okay. So here's another one for us. 2 times 5x plus 1 plus 10. So the instructions would be simplify. And so the plus 10, we can't do anything with it until we deal with this. And so the parentheses, you would love to add these two, but we can't because this is an X term and this is a plain number, and the two are not the same. But we can do this, distribute. And so we will. 2 times 5x, 2 times 5 would be 10x, right? Plus 2 times 1 is 2. And so you can always double check. Did we do that right? Yes, we did. But then there was a plus 10 added to it. And now I have 1, 2, 3 terms. If any of them are alike, you have to deal with it. And so this one and this one are in the same category. They're plain old numbers, no X's involved or any other letter. So this would be 12. It's plus 12, and the 10X is just copied down. So you cannot do anything more with this. Don't be thinking you can add 10 and 12 and think that's good. This is not 10, not in any way. This is 10 times X, and we have no idea what X is. So you better leave it just the way it is. It's happy. 10X plus 12. How is that? Good enough? So you do your parentheses, and then you say, will anything work? And notice it's the add or the subtract that's separating the terms. This, this, this. And I'll have more to say about that more later. So here's another one. If I had, this is another skill they're asking you to do. The instruction would say, find the value of the expression, find the value of the expression when X is 5. Let me bring it down so you can see it. So the instructions read, find the value of this expression when X is 5. In some books, they use the word evaluate, which is really the same word. And so X is 5, which means we're going to substitute. So when we substitute, we now know what X is. So when you substitute, your very best plan is to use parentheses right like that. So the X is replaced with its equivalent, which is 5, and I'm putting parentheses around that and dropping the 5 inside the parentheses. And then it's a plus 2 at the end, which I can't ignore. Now, part of the reason for using parentheses is when you have negative numbers, honestly, you'd be in real trouble trying to keep track of everything. So it's a good habit to use parentheses when you substitute one letter for the number. This is also a reminder that this is multiply. 3x with nothing between it means multiply. It's an assumed multiply. But then the parentheses is reminding you again, oh, I got to multiply. And you can't do anything with the addition until you've multiplied because of order of operation. So this is 15 and this is 2. And in the very end, you do your adding. So this is all about order of operation. So let me see if I can find another one of that nature. Let's see, -8 plus 3x. They want to find the value. That's the key word. And still X is 5. Okay. So you write the problem down. You then very carefully get to the letter, use parentheses, drop your number in, and close the parentheses like that. So when I see, let's say you messed this problem completely up. When I see that you have the right formula to start with, you copied it correctly, and you drop the number in, I would give you partial credit if you stopped right there. Because this is the crucial step that the letter X, which is really a number, was replaced with its value of 5. And so this is the crucial step. Now, can you finish it? Of course. You have to multiply first, which is 15. and there's a -8 here. And so 15 and -8, anybody want to venture? Yes,
Seven.
yes.
7.
+7, you got it.
Oh,
Okay. So let me do this one. -7a plus 4. And then they say, find the value when a is -2. Well, when the number you're putting in is negative, it's more important than ever to use parentheses. And I've seen this a million times. This is the way to do it. Not that you can't do other ways. Here's the problem. Here's the original problem. I get to my letter, I put parentheses, I drop my number in, close the parentheses, and then I finish copying. That's the critical step. And that's why I want to see your work, because if you get past this, you're going to make it. If you don't, or if you try to like take a shortcut, this is not a bad step. This is a critical step. So now the multiply has to be done next. A negative times a negative. Are you remembering this from chapter 10? Positive. So 7 times 2 is +14. You add your 4 that was just sitting there, and these two are like terms. Okay. So they want you to practice this. This is beautiful stuff for algebra. You want to be really great at this. Okay? You're going to be great. Nobody's smiling. Come on.
We're laughing, we're not smiling.
You're going to be great.
I'm doing jazz hands over here. I didn't.
You're going to be.
I didn't know this was the Blind Side movie. No, I'm kidding.
Oh, this is going to work out just fine. So they have a stupid one where they plug in 1/3, find the value. So let's just do that just in case. So this is identical. And so this is the value they want to put in for this problem. So it's 4 + 6 parentheses. I love parentheses. This is 1/3. It's doable. And then you've got to deal with this first because it's multiply. Notice how I write my 6 kind of high, so it's all kind of ready to go. So the 3 and the 6 could reduce to 1 and 2. So 6/1 times, if you need to write it more properly, like that. But then 2 times 1 is 2. So this whole mess is 2. This was 4. This is add, answer 6. So don't panic just because you see a fraction, who cares? Chances are it'll work out pretty nicely. Okay. Now, oh, they do stupid problems. Let's see. They have a square and they label one of the sides as X. We will never know what it is, by the way, just keep that in mind, but it's X + 1. And they want to know what would be the perimeter. So this is kind of working with what we just did. What would be the next side?
X + 1.
Every one of them is going to be X + 1 because they told us it was a square, or I think the shape, the way they drew it, was very clear. So you could label all 4 sides if you need to. You could have also gone 4 times X + 1, because that would have done it. There's 4 identical sides and each side was X + 1. And then you could have distributed it. Or if you had labeled all 4, you would have had how many X's? 1, 2, 3, 4 X's. You would have had 4X, and then you'd have had +1, +1, +1, +1, +4. So there were 2 ways to do it. But this is one thing I want to talk about. Although we write this as X, because we have so much to write, we just want to make it as simple as possible. Each was really 1X. So we never forget when we see X, the other version or the other way it amounts to is 1X, which makes it easier to see that 1 and 1 and 1 and 1 make 4X. And so I think whether you had to write this or not, eventually you get used to that's 1, 2, 3, 4, 4X, but I wanted to point that out. Okay. So if they did something silly, like made a triangle, and this one is 4X plus 1, and this is, it doesn't matter what it is. They're just playing with you. They just want you to get the perimeter based on this picture. It's a triangle. There's 3 sides to add. And so what you have to do is add the like terms. So I would add the X's. There's 4X here and 4X here and 5X here. Those are like terms. And so 4 and 4 is 8 and 5 is 13X. I'm making a project of this, but you may not need to. And then the numbers are 1 plus 1 plus another 1 plus 4. 13X plus 6. And so can you add these two? Never, never, never. And if you start to do it in the next course, I'm going to haunt you and say, don't do that, don't do that. So listen to your gut, because I'm going to come back and get you.
Good.
You can't do that. 13X is completely different than this. This boiled down to, if we had 13 feet and 2 inches, we couldn't add them and say it's 15.
No.
Could we?
Nope.
Or worse than that, if I had 3 pens and 2 papers, I couldn't add that and say that's 15 because they're not alike. And this was the point I tried to make at the very beginning. When you add, the assumption is you're adding like things. And so all of those X's are alike. And so I put them together and called them 13X. And then the numbers, the simple numbers or the plain numbers were alike. And so I added those together. There's nothing more I can do but say this is the total of what I have. Is that okay with you? It's a critical thing and I never see it in a book. Never. It's like it's so obvious they forgot to mention it. I remember seeing a calculus book. I'll tell you this real quick. So I was 18 years old taking a calculus course. And the book said, I never forgot that. This is decades. They said, oh, blah, 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 blah. This is intuitively clear. And I screamed. Intuitively clear? Oh my goodness, what are they thinking? You know, it was not clear to me one bit, but you know what, I'm such an ornery person that I just kept trying. They have a few problems like this. These 2 lines form a 90-degree angle, which is, these are perpendicular. And they do a couple little problems of that. This whole measurement is 90 degrees. Does everybody kind of know that? 90 degrees. So they play games with this. If, for instance, on this side, this measurement right here was 30 degrees, then could you tell me the measurement of the missing angle? So what is it?
It's 40.
I don't like 40.
60.
60.
60, I like 60. So that's basically it. So you could make a project out of this. 30 degrees plus X is 90 degrees. I mean, that's what it amounts to, isn't it? And then you can probably see that makes this 60. And so that's, they wanted you to, they wanted you to get a little more
Confused.
geometry, right? All right, so they did that. They did one other one, and if straight up is 90 degrees, like I just drew, this is 180 degrees. So it's a 90 on the left and a 90 on the right, and it's totaling 180 degrees. If this on this side was 50, could you then tell me that
Yeah,
this one,
130.
130, that's
130.
that's all there is to it. And so they just wanted you, they're just giving you a little bit of geometry along that line. How's that? Now, that's not critical to where we're headed. Here's where we're headed. This is not something to simplify. This is an equation. And so they will say solve for X or whatever you've got. So it could be an A or a B or any kind of letter, but they love X. So how do you know it's an equation? Well, it has an equal to sign. It has some expression on the left and something on the right. That's an equation. What you really want is to know what X equals. Now I'm starting out pretty easy because this you could guess. But what I want to do is show you the procedure. On the left side of equals is X plus 5. And what we don't want X plus 5. Who cares about it? We want X. And so what we need to do is get rid of the plus 5. And in each case, what we're going to do is remove it by doing the opposite. Now, the opposite of adding is subtracting. And the book tends to write it on the same line. I tend to write it right below. Somehow I find that easier to see. And so the plus 5 and the minus 5 makes this X plus 0. And on this side, 7 take away 5 is 2. Now you can't just subtract on one side and then not subtract on the other. So you've got to do it to both. Now X plus 0 is X. And when you're done, your answer, when you put it back here, the 2 and 5 is 7, will check. And so each one of these problems will be locate the X or the letter. Wow, this one's slightly different. It's letter A. Does that matter? No, not at all. We love all the letters. The trouble with this one is that this is simplified and so is this, but we have letters on both sides of the equation. And so this is what I would recommend you do. This is 7A, this is 3A. I would always target the smaller one. This is assumed to be plus because there's no negative on it. And so I'm seeing this as plus 3A. Here's what I'm going to do. I'm going to subtract 3A from here, and I'm going to subtract 3A from here. Notice that I wrote it right below the matching term, so that 7A take away 3A is 4A. This is still in play. So I copied the 4, I simplified this. 3a minus 3a is 0. I got rid of it. And what's left? Not 2, but -2. I don't know why they put this problem next. This one, I've got the a over here. It's multiplied by 4, but I also have a +4. I was looking at the book. This is a multi-step problem, and I have no idea why they listed it first. I'm going to put this aside real fast. I'm going to start with this one. This is 8 times x, subtract 5 is 11. I need to get x alone. There's 2 problems. There's the 8 and there's the subtract 5. This is a 2-step problem. And so what I need to do is move the single number off first. And so the subtract 5 is done first. And I'll write this out for you in a minute. Subtract 5, I want to add 5. 11, I want to add 5. The -5 and the +5 are gone. And I'm left with 8x. The 11 and the 5 make 16. We learned the next step earlier. Do you remember what we needed to do? This one.
Divide. Multiply.
Divide. Do you remember that? We're going to divide by what number?
8.
Correct. And divide by 8. 8 divided by 8 is 1. 1x is x. 16 divided by 8 is 2. And even that, I don't like the book's approach. So it's a few minutes. I'm gonna do it my own way. X plus 3 is 10. This is a 1-step problem. 1 step and I'm done. And so with the +3, I would subtract 3 on each side. I'm going to just throw that out if you don't mind. This is x, and 10 take away 3 is 7. Is that good? That's a 1-step problem. I want to do it with this. If it had been subtract, this is still 1 step. It's the subtracting 5 that I have to get rid of. To deal with it, I would add 5 to both sides, and I literally put it below it, and I say plus, so I don't get confused that I thought it was minus or something. The -5 plus 5 goes to 0, and I'm left with my x. This is 16. Four x is 12. This is 1 step. This is the one that you do know. This is assumed to be multiply. The 1 step is to divide. 4 over 4 is 1. 1x is x, and this is 3. 1 step. You figure out where the x is. You look to see what's there, and you do the, and so on. There's one more in this category. If the problem was divide to begin with, the opposite, what is the opposite of divide? Multiply. So I would multiply by 3, and I would multiply by 3. And this is, the 3's would cancel, and you'd be left with 1x, and 10 times 3, you'd be left with 30. I think these problems make sense. 1 step, identify the one step and do the opposite and do it to both sides and be very, very clear. I added, I added. I multiplied, I multiplied. I divided, that kind of thing. Okay, that's our start. This is the start of a two-step problem. And for some reason, they didn't have things in the correct order. And so this is what I want to show next. And I think I'm going to stop after that. The X is on the left. There's two numbers that need to be dispatched. 2 and the 1. Without explaining it, we always move the single number first. It simplifies life, it avoids fractions. It's a very good thing. So I would remove the +1 as my first step. And to remove a +1, I would -1, both sides. Okay, so that's what I'm saying. Do it that way, you'll be glad you did. +1 minus 1 is 0. I can take that out and I'm left with 2x. 7 take, and that's why I carefully, when I do something on the left, I go ahead and do it on the right so I don't forget. 7 take a what? Wait, 1 is 6. Now we're back to a one-step problem. The x is multiplied to 2. So my decision is to divide. What do you say? I don't like the problem that I picked up one out of the textbook. And it involved too many steps. At this point in time, I believe we could finish this particular problem. Here's the letter, it's multiplied and it's added. Which of these two 4s do I get rid of first?
Just the whole number, 4.
Whole number, the +4, exactly right. I may explain it. This is subtract 4, and then I better come over here and do the very same thing. The +4 minus 4 is 0. We can just take that out of the picture, and I'm left with 4a. And I have to combine these. So if I have a -2 and another -4, how much do I have?
-6.
Correct. We kept going further down. And so now I'm down to a one-step problem. It's 4 times a
Divide.
divide. And the more you
Divide by
do
4.
these, it'll become rote, it'll become easy. It's -1 negative, which means the answer will be negative. The 6/4
Is 3/2.
3/2. The final answer is -3/2.
Hey, I was right.
So this particular problem had too many steps, and I'll organize it for you very nicely in another class. The problem with this one was that there were letters on both sides. And you need to have them on one side or you'll never get it solved. So I targeted this smaller one. And there's a good reason for that. But it was a +3a. I subtracted 3a from each side to take that out and have the letters only on one side. And so 7 take away 3 is 4a. I copied the rest. I then targeted this +4, the single number, the whole number, not the letter, one with the letter, but the single number. Take that out first. And then finally, I had the one step left to do, which turned out to be division, same number, and then I reduced it. Okay, what do you think? So that was a messy explanation, but nevertheless, I do believe you can get started. I moved 8.4 to Sunday. I don't know if you saw that, so that you had a little more time to deal with it. And if we need to move things, I will, because this is important. And so I don't know what's due today.
11.1.
Just 11.1. So I pushed it a little bit, but let me stop the recording.